Hi, I'm Mr. V, and this video is on cross products and proportion problems. Also, it could be called ratio problems, but here we go. We're going to jump right in. Example number 1. We're going to solve x divided by 8 is equal to 3/4. We're going to solve for x. This is a great question because it's something you've done before. You actually had this on a warm-up question probably, and we know how to do this with equations. Like, that is actually like the main thing to keep in mind, that this is not something that's radically new. This is something that you have seen before. We start for our equation. I'm going to draw my balance line. I'm going to rewrite. Okay, everything's good. Well, x divided by 8, the inverse operation of dividing is multiplying. I'm going to multiply by 8. This is equal to 1. X is equal to, and you can do this a number of different ways at this point, I know. 3 times 8 is 24 divided by 4. And that's equal to 6. Done. X equals 6. Perfect. We know how to do inverse operations. Now it comes time to bring up something else called cross products. Cross products is another way of doing this, and it's a little different, and it helps us when we come up with table problems. And you might be like, what's table problems? What do you mean? That's with proportions, and that's going to be in 2 examples. Here's how cross products works. I'm going to start the equation. I'm going to draw a balance line. I'm going to rewrite. Except I'm not going to rewrite like that. Normally I'm like, yeah, rewrite, totally. There's actually something you need to do before you do that. Or there's a certain way you need to rewrite. When you rewrite, I'm going to draw, I'm going to color that one X in green. I'm not going to color the 8 in the same color. I'm going to color the 4 in the same color. That's across the way. Same thing with 8 and 3. The way cross products works is it's the number that is across from it. You're going to multiply it together. What do I mean by that? I mean you're going to take 4 times x and 8 times 3. You're going to multiply the numbers that are across from each other, together. 4 times x is 4x. 8 times 3 is 24. And ta-da, there's no more division, there's no more fractions, and if the variable was in the denominator, that's going to happen. Oh yeah, the variable might have been the denominator. We just cleaned it up like that. Now it's a normal problem. What's the inverse of multiplying? Oh, what was I supposed to do? Rewrite first. The inverse of multiplying, though, is dividing. I'm going to divide both sides by 4. X is definitely equal to 6. So you might be thinking, I'm cool with this. I'm good, Mr. V, which is fine. It's just cross product is another tool, and it's really useful when the variable ends up in the denominator. Let's go ahead and do example number 2. Hey, look, example number 2 should look fairly familiar. It's the same numbers I used on a warm-up a couple days ago. Start with my problem. Balance line. Rewrite. Let's see. The inverse of dividing is multiplying, so I'm going to multiply by 22 on both sides. 22 times 2 is 44 over 7. Don't multiply both of them by 22, so n equals 44 over 7 is what n equals for its final answer. Okay, cool. Let's go on to the next one. Let's do cross products now. I start the problem. He started with a problem. Sorry, movie clip type audio just started in, and that's a horrible balance line. I apologize. I'm gonna do the color code thing probably for the rest of the quarter. That's 2. That's gonna be 22. That's 7. That's n. 2 over 7 is equal to n over 22. Very Christmassy. Okay. Cross multiplying means I'm going to multiply across the boundary. I'm going to take 7 times n and then 2 times 22. See, 2 times 2 is 4. 4, and that's 44, right? That's 7n. Now I still have to do a little bit more work. Quite often, that's life. Inverse of multiplying is definitely dividing by 7. This equals 1. So n equals 44 over 7. Done. You're probably still saying, I don't really see the point in doing this. This is kind of useless. And you know what? If it was just me, I would probably stick to this. But, this is a big but. It's going to come to the point when the variables are going to end up in the denominator in these problems. And this isn't just Unit 5. This is Unit 5 and 6. This is how we're finishing the second quarter. This is how we're starting the third quarter. And so, this is a big deal. This is something that you're going to be doing in 2 different units. So, want to hit it hard. Example number 3. We have a word problem. Example number 3. Zach's world-famous omelets use 5 eggs for every 2 omelets. So let's take a moment and think about this. In his recipe, he uses 5 eggs to make 2 omelets. Okay. He had 18 people over for a sleepover, and everyone had 1 omelet for breakfast. How many eggs did Zach use? Okay, so Zach's got 18 people over, and everyone had an omelet, so he's making 18 omelets. So you're trying to think about, okay, how many eggs did he use? Now, this is going to sound familiar. This is just like the project that we're going to be doing with the cooking recipes. This is the table part. I don't expect you to do this with triples. With the table, you're going to be doing this. This is it. This is the assignment. You're going to have to do this for all these ingredients. You're going to have some recipe. You're going to blow it up for a number of people. And then you're going to have to use the table to show me that you know what's going on. So, first off, let's give it a shot to triples. Let's say this is for omelets. Okay? And let's use this for eggs. Now you might say, why are you using green for eggs? Green eggs and ham. Yes. All right. Let's see. I got spit in my eye. Sorry. 5 eggs. 1, 2, 3, 4, 5 for every 2 omelets. How many omelets am I making? I'm making 18. Every 2 omelets I make, 6, 8, 10, 12, 14, 16, 18. Every 6 omelets I make, or every 2 omelets I make, I'm going to use 5 eggs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 8, 9. So for every 2 omelets I make, I have to draw 5 eggs. This is how the Triples method works. Count them eggs up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10, 20, 30, 40, plus 5, 45 eggs. So he's going to have to make 45 eggs. We're just going to put 45 eggs right there. We're just going to mark 45 eggs. Yes, I want your answer in a complete sentence. That's not a final answer. I'm just putting a note right there. So that's how you would do it to triples. That's a lot of pictures. That's not really the best way to use your time. Let's make a table. There's a way of doing this by making a table. And this is the table. This is it. This is the 2/4 of doing this. First off, you make a table with 4 boxes in it, like when you play Foursquare. Then you're thinking about, okay, in these two are your 2 different quantities. We have eggs and omelets. Eggs and omelets. Omelets on top, eggs on the bottom. We know, and that's the first column, we know that it takes 5 eggs to make 2 omelets. We know that. The question then becomes, oh, there it is, question. How many eggs, doesn't get much simpler than that, how many eggs does it take to make 18 omelets? Once we've made that, then we just make our equation and we solve it. This is 2/5 is equal to 18 over x. And then you just solve it. And you might say, what happens if I just flip this upside down? That's fine. It'll still give you the answer. But you've got a variable in the denominator. And that is the trick part. That gets a little dicey. And you might think, no problem. 18, 2 times 9 is 18. 5 times 9 is 45. That's how I'll do it, which is fine. What happens if you end up with a decimal? That's example number 4. I'm going to write it out. 2 times x, because I'm cross multiplying 5 times 18. So this is 2x. This is 5 times 18 is 90. I'm going to rewrite. The inverse of multiplying is dividing. So x equals 45. Okay. You have to have the complete sentence. So, here's your sentence. Zach needs 45 eggs to make 18 omelets. That's your complete sentence. Because x equals 45, what does that mean? 45 eggs. Great. What the heck? Bunch of circles that look like colored Christmas bulbs. I don't understand. You have to write down a sentence, a complete sentence. Because all this work doesn't really mean much unless you write a sentence. It doesn't make sense. You're not going to Zach's not going to call his dad and be like, hey, I need 45. Yes, son, 45 what? Like 45 what? Oh, I need 45 eggs. I'm not giving you 45 eggs. I need 45 eggs to make 18 omelets. Oh, you got to give us a complete sentence. Example number 4, and that is it for tonight. By the way, Mr. Heiberger is a fantastic painter if you didn't know this. I've heard. He paints houses. A shade of paint is made by mixing 5 parts yellow paint with 6 parts green paint. And the parts could be gallons, quarts, cups, whatever. It just means that when you mix that ratio together, it gives you a certain type of green. If Mr. Heiberger only has 15 quarts of green paint, how many quarts of yellow needs to be added to get the right shade. Okay. This is not it's not doable with triples because I'm gonna let you know right now it's not gonna be a whole answer. Because like 6, okay, well 15 is green and the green is in 6. Okay, so 6, 12, 18. No, I need 50. Oh man, dude, I can't do that. No way. Yeah, it's not gonna work. So here we go. Table. And it's always going to be a 4-square table. I don't know why I just made it so big. I think I'm going to trim it down a bit, just like that. Okay. What type of colors are we using? We are using yellow and green. We know, so notice I put here my quantities, bam, bam. I know, it's the first column. I know that there are 5 pieces of yellow or 5 parts of yellow for every 6 parts of green added together. Okay? If Mr. Heiberger only has 15 quarts of green, he has 15 quarts of yellow? No. He's got 15 quarts of green. How many quarts of yellow needs to be added to get the right shade? So that's our N. That's what we're looking for. And by the way, yeah, the letter right there, whatever you want to use. Don't, like, you make a letter, use the sentence, number of quarts. Or use Q for quarts, or yellow, Y for yellow, whatever. Okay, that just gave me my equation. 5 over 6 is equal to N over 15. Balance line. And now I have a choice. I can either cross multiply or I can do this like a normal equation. It's up to you. I'm going to cross multiply. I'll do this with the colors. 5, 15, 6, and N. These are equal to each other. Okay, gonna multiply. 5 times 15 is equal to 6 times N. So I've got 6N is equal to 5 times 5 is 5. Carry to 2. 5 times 1 is 5, plus 2 is 7. I'm going to divide both sides. Oh, I'm going to rewrite first. I'm going to divide both sides by 6, and then I'm going to get N equals 75 over 6. You can't walk into a paint store and say that. I need 75 6. What's that mean? I don't know. We got to simplify it first. Hey, simplify. One of those things that we still know how to do. I can divide top and bottom definitely by 3. So we get 2 on the bottom. 75 divided by 3 is, let's do long division for that. 3 goes into 7 twice, minus 6, bring down to 1, bring down to 5, and 5. Hey, 75, or 25. Cool. 25 and a half. Got to turn into a mixed number. This goes in 12 times. And then we still have to have an extra half quart. So, what's my answer? What do I put? Do I put this? Do I put 12 and a half? Got to give me a complete sentence. Nope, it's not 2 words, it's 1. I knew that. Oh, it's an E, not a U. Mr. Heiberger needs 12 and a half quarts. So you got to have the units, you got to have all that. 12 and a half quarts of yellow paint. A lot of work. These problems are very, very long. and they can get very, very tricky. Oh, I even forgot to put my thing on here. This is the question. If you take your time and you're very neat and organized about this, these problems are very doable. Okay, be ready for this. It's a lot of word problems. It's a lot of fun. See you next time.